All right, I'm going to go ahead and start with announcements because I got a lot to cover in the next 3 days. I want to cover the law of cosines in the next 3 days in vectors. So, first of all, the last day of class ends on Tuesday, November 24th. Last day of class ends on Tuesday, November 24th. On Tuesday, November 24th, I want you to turn in your projects. I want you to send me an email with Math 111 project in the subject line. Okay, let me say that about 4 or 5 times. Please put in the subject line Math 111 projects. I've got 2 other classes with projects. And if everybody follows directions and puts their section, puts their course and section in the project subject line, I won't have any problems. Please follow the directions. Send me whatever you have, whether it's word processor or Excel. I would prefer you write it up and include the pics, include whatever the work, and just scan it and send it to me. Organized and good prep goes a long way because this is not my project. This is a project that I'm having to do for some bureaucrats. So I need you, each one of you, to do a good job in writing it up, adding the pictures, the diagrams, whatever. Scan it because sometimes you got to write on the paper, you know, the diagrams and everything. Scan it and send it to me. Don't send me a bunch of junk, okay? Because I'm not even going to grade it if I can't read it. Make sure you put in I only have 1 trig class, so all you got to do is put Math 111 project and send me the attachments, preferably scanned, because if you have to write on it, you're not going to be able to send it to me in the word processor if you need to write on it. So you have to scan it. If you wrote on it, if you've got everything in there in the word processor, that's fine. Send the word processing file. But just make sure 2 things. Make sure it's complete and make sure it's organized. I don't really care, you know, about the math part. I mean, I'm going to grade it, of course. I'm going to look at it. But it's very simple. Most of you should have been able to do it without any problems. Okay? Any questions on that, on turning in the project? It's 10% of your grade. And if you don't turn it in, you're going to get a 0 for the 10%, and that's going to drop your grade. That's the lowest I can put on it. Okay. Also on the 24th, your final exam and your last test will start. Your last test will consist of 11.1, 11.2, and 11.3. That's law of cosines, sines, cosines, and vectors. I thought about trying to do a little bit more, but I'm not going to try it. Okay? That's going to be your last test. You will have 2 weeks, and I'll give you 2 weeks on the homework also. From Tuesday the 24th for 11/24 through 12/7, you will be working on the last test, the final exam, and the homework for that last test. So I think that's fair to give you to the 7th on that homework. Okay? I'm going to go over it today, Thursday, and Tuesday. And it's really not difficult. In my opinion, the identity test is probably the most cumbersome for students. So and some of y'all made A's and B's on the test. So that's a good thing. So I think you're through the hard stuff, because this is not difficult. And the last test will cover those 3 sections. Okay? The final exam, you'll have 2 attempts. And of course, like I've been doing all semester, I take the highest grade. You'll have 25 or 33 questions. They will all be math questions, no bonuses. And I usually take questions from the test. And if you want to review the old test, you just go to your grade book and hit the review link, and you can review your test. I usually make the test an hour, around an hour, and I give you 2 hours to take it. That way everybody has double time. And remember, the 24th through the 27th, or through the 7th, is exam, last test, and homework on the last test, 11.1 through 11.3. Also, if you see something funny or something different on MyLabs Plus, are you supposed to write me an email and say I'm confused, or are you supposed to go with it? That means you go with it. You don't write me an email and say, I'm confused. Okay? You go with it. If I was to give y'all back a hard copy test and I accidentally gave y'all 10 points extra, would you raise your hand and say, Hubert, you made a mistake and gave me an extra 10 points?
No.
Okay. Then if you see something on MyLabs Plus and it goes, well, golly, that means I can do this and I can do that, don't write me an email that says, I'm confused. Okay? Please don't, because I'm not going to respond to you anyway. Okay? Question. Some of you may have already seen it. Okay, did that answer all the spazzed out hammy questions that y'all can think of for the last week of class?
Yes, sir.
Some of y'all already thought about those questions, haven't you? I know you have. All right, well, that's it. And it's on the recording now. So I'm not going to answer those questions from here on out because they're on the recording. Now, also, did anybody see the file that I sent you several hours ago? Anybody? 6 hours ago.
I haven't looked, no, sir.
Okay, if everybody goes to the file, I'll show you right here. Everybody see that? New. See, it's got a little sparkle there. This item is new. What does it say? Law of sine, cosine. See that? Everybody with me? You need to go out and print that out. Looks like this. That's what it looks like. That's what your whole test is going to be on, that and vectors. Okay? So it's not hard to write down. Now, if you're at home and you're near a printer, please go ahead and print that out so you won't have to write all this down. If you're not at home near a printer, then just try to write down as we go. You don't have to write all this down right now because I'm going to go over this first. Okay? So let me go back. And there is the new, it's just the one it's got a little, I don't know what that is right there, a little sparkle or something right there. Law of sine, cosine. 6 hours ago. Yes, 5 o'clock in the morning. Y'all are special. Okay, so let's start. First of all, what is the law of sines and cosines about? Well, the law of sines and cosines is basically, do you know where your right angle trig addressed a 90-degree triangle? And you found the sine, cosine, the tan, and so on. And you use the Pythagorean theorem to find out sides and lengths, and you use the sine to find out sides and lengths and angles and all that. Well, the law of sine and cosines is going to do you with those triangles that are what?
Not 90 degrees.
Not 90 degrees, not right triangles. And that's the law of sine and cosines. Now, the only thing that you need to know before we start going over the law of sine and cosines is two things. You got to know that when you're talking about a triangle, and this is not to scale, it's not meant to be any certain type triangle, it's just a triangle. The angles are going to be capital letters. And the sides are going to be opposite the capital letters, and they're going to be lowercase letters. Now, the reason I'm showing you this is because there's a lot of people that don't know that, because there's a lot of people that's never had a trig before. Okay, so I've got to make sure everybody understands that when you're talking about the law of sine and cosines, capital letters are your angles. Lowercase letters are your sides. And they are opposite of each other. So if you got a big C here, your little c is going to be opposite. Also, the second thing you need to remember, where's my red pen? Y'all know I have run out of red pens. The other thing that you need to remember is, what does a triangle equal in degrees?
180.
Is that important? Yes, it's very important. Because if you get one angle, if you know one angle and you know another angle, then you just have to subtract those two angles from 180 to get the third angle. All right? And there's going to be instances where this rule right here will help you out, and you got to remember that rule. So before you even start law of sine and cosines, you need to be able to understand that with a non-right triangle, capital letters are angles and lowercase are sides, and they're usually opposite of each other, and that a triangle is equal to 180 degrees. Now, I'm not going to go through the derivation of, hold on, I'm trying to find my dadgum. I'm not going to go through the of the law of sines and law of cosines because I don't think it's needed. unless you're just weird, okay? And these are things that take care of side, angle, side, angle, side, angle, side, side, side. And they're going to show you, here's how you basically get the law of sine and cosines. I'm not going to go through that. There's the law of sines. And hopefully we'll get to an example right here. All right, so here's an example. And write this down because I'm going to cut all the fat in these three sections. I'm only going to show you problems that I would ask you on the test. We're not going to spend a lot of time on hoopty-nootny stuff. We're going to just go right to the meat. Okay, so solve triangle ABC if A is 32 degrees, B is 81 degrees, and little a is 40. So I'm just going to draw a triangle. Hold on. Blame it. I'm sorry. I'm trying to get my handy dandy. I'll just draw it. Y'all draw it and I'll draw it and then we'll do it together. So I'm going to draw a triangle. Just going to be a triangle that has no shape, no certain shape to it. Angle A is 32 degrees. Angle B is 81.8 degrees. And side A is 42.9 units. I'm going to say units because it doesn't matter as long as you treat the units the way you're supposed to. I got something that looks like this. Okay, now right now we can go ahead and we can figure angle C. Angle C is equal to 180 minus 32 plus 81.8. That's one way to find it. Another way to find it is to use the law of sines and cosine. But how many in here likes, to be beaten with a whip and chain? I don't. I don't want to go through extra work when I can get the answer with a simple mathematical, okay? Keep it simple. So let's take our handy dandy calculator and let's take 180 minus parentheses 32 plus 81.8 close parentheses. Look at there. So angle C is equal to 66.2 degrees. So we already got angle C. So I'm going to take my handy dandy pink highlighter. And we found angle C, 66.2 degrees. Now, I'm not going to try to trick anybody on this test. I'm trying to get you the law of sines and the law of cosines. You're going to use them later on, mostly in Calc 2. Okay? But you need to be aware of them for your vectors and your free body diagrams in physics. And you might be taking physics along with your first calculus. So that's why you need to know the law of sines and cosines fairly well. So I'm not going to try to pull any punches, and I'm not going to try to get you to rebuild the space shuttle with some of these problems. They're going to be very short and sweet and to the point on your test. I can't say that for your homework, but for your test, it's going to be very to the point. Unless y'all want me to be around the world. You want me to go around the world on the test? I'll be glad to. You want me to?
No, thank you.
All right. So now we got to figure, we got A, but we got to find side B and side C. Well, Hubert, the directions, I don't care what the directions say. When you're given a problem in homework, find all the sides. That way, when you do 20 problems and you find all the sides, you're very confident in working 10 problems on the test and just finding little pieces. So I tell students to find everything on every triangle. So I'm going to take my handy dandy green turquoise looking marker, and we're going to draw B right here and C right here. So law of sines, because we ain't got into law of cosines yet, so this is going to be law of sines. And you'll be able to tell the difference. By the time we get to law of cosines, you'll be able to tell the difference between. Now, I'm going to go back to the Word document. I'm not going to write it on the page. I just want you to, there's the law of sines and law of cosines. I write mine like this. Okay, I don't do this. You do whichever one you want, but I'm going to write mine like this. So I'm going to write the whole thing at the top of the page. A over sine of A equals B over sine of B equals C over sine of C. Now, somebody that's familiar with the law of sines and cosines, tell me, what am I thinking about when after I've gotten my C right here, what am I thinking about as far as the law of sine and cosine and my triangle? Anybody want to volunteer? What am I thinking about?
Plug in the angles and lengths of the sides that you already have.
Exactly. Find out what you're given, and then figure out what you got to get. Okay. So the first thing I'm going to do is I'm going to highlight in green what I have. Well, the biggest thing I have is I have this guy right here. Well, that's this guy right here. Well, that was about stupid. Now I got to write that in black. I didn't think about that. There. Okay, I've got side A. So that means I have to have angle A to work with this. So angle A, I've got angle A. So I've got sine of A. So I've got that right here. What else do I have? Well, now that I have C or B, so it's your choice. I've got angle C, I've got this, or I've got angle B. I've got this. So I can use either one. Since B is beside A, I'm going to use angle B. So this is how you use law of sines. I'm going to find B. So A is 42.9 over sine of 32, and that's equal to B over sine of 81.8. And now what do we do? Basic algebra 1, what do you call it?
Cross multiply.
Cross multiply and solve for X. In this case, cross multiply and solve for B. And that's it. So I'm going to write it down for you as soon as I get rid of that camera icon. So 42.9 times the sine of 81.8 is equal to the sine of 32B. Now, how do I get B by itself? I divide both sides by the sine of 32, and I get 42.9 times sine of 81.8 divided by the sine of 32, and that's equal to B. So I need somebody to get the handy dandy calculator out, and well, I'll do it because y'all don't communicate with me. So
It's 80.128081.
oh my gosh, you're communicating with me, Mr. Wexler. You're not supposed to do that. They're going to beat up on you.
I'll keep my mic.
B is equal to what?
It was 80.128 and then round 1, I guess.
128. So 80.1. Somebody tell me why I rounded to one digit.
Because of the significant figures to the tenths.
Right here, because the question started with the 10th. One rule of thumb in mathematics, physics, science, you finish what you start with. If you're not given directions to round, you finish what you start with. So I started with tenths, end in tenths. And now we know that side B is equal to 80.1 units. Now I want you, each one of y'all, I want you to find side C for me, however you want to. You've got multiple ways of doing it. You should get the same answer. So go ahead and do that. And I'll do it on another page. I'm going to give y'all a minute to get started. Find side C. Right here. Okay. Now, I'm just going to say, I don't really care since B and C are side by side. I'm going to use B. You could use A if you wanted to. So B is 80.1 over sine of 81.8 is equal to C over sine of 66.2. Cross multiply. Now, after you do about 3 or 4 of these problems, you're going to find out that all you got to do is rewrite this and divide by this. Okay, so I'm just going to go ahead and do that. 80.1 times sine of 66.2 divided by sine of 81.18. Sorry. And that's equal to C. And if somebody could give me a tenth, please.
74.1.
I'm sorry, 74.1.
Yes, sir.
And that's your answer. So C is equal to 74.1. That's how you do the law of sines. To this day, I remember when I was in trig, I made an A on the law of sines and the law of cosines test Do you know why? Because it was the easiest thing for me. Don't ask me why. But for some reason, I latched on to this a whole lot easier than I latched on to a lot of other stuff. So let's check our answers and see if we know what we're doing. Is that the problem? I guess that's the problem. $80.1 is B. Ding! 66.2. Ding! 74.1. Ding! All right, you try this one. Ooh, this is a surveying question. So this is the type I would give on a test. So I want y'all to do this one. Write it down, and I'll be writing it down while y'all are working it. So there's one good test question we just went over. This is a second good test question. And if this is land surveying type problem, you can bet your bottom dollar it's going to be on the test. Give y'all a couple more minutes. All right, the first thing I would do is I would find angle B is equal to 180 minus 112.9 plus 31.1. Well, that's not too bad because 1 and 9 is 0. And that would bump that up to 32, or let's see, 144. I got 144 degrees. Somebody check that in the middle right there. Is that 144 degrees?
Yes, sir.
Okay. And I don't need a calculator to do this. 180 minus 44 is like 36 degrees.
Yes, sir.
So our angle B is 36 degrees. Now, why do I do that first? Well, because it's not that difficult. So now that I've got all three sides, or all three angles, I can pick whatever I want. So I'm going to pick C first. So I'm going to go down here, or right here, and I'm going to do C. I don't know C over sine of 112.9 is equal to, well, I can pick whatever I want to. Since B is smaller, don't have a decimal, I'm going to pick B. And I'm going to say 347.6 over the sine of 36. Now you could have picked A, and as long as you pick the right numbers for A and sine of A, you'll get the same answer I get. So I'm just going to write it out. C is going to be equal to 347.6 times sine of 112.9 divided by the sine of 36. And somebody give me the 10th, please, of all that.
I got 544.8 for C.
544.8.
Yes, sir.
And now let's do A. Well, now that you got B, you got B, we got it right here. Just take B and let's set it up for A. So 347.6 over the sine of 36 is equal to A over the sine of 31.1. So A is going to be equal to 347.6 times the sine of 31.1 divided by the sine of 36. And somebody give me to the 10th there.
I got 305.5.
So here, part 1, I found the angle. Part 2, I found one of the sides. And part 3, I found the remaining side. You do your own method, okay? But you're going to be doing the same method I'm doing. You just may do it in a different order. Now, some of y'all may be saying to yourself, well, I can't believe this is that easy. Well, it is. It's very easy, unless you just like to mess things up. And if you can mess things up, then you can mess this up. So I don't know. We'll just do the best we can. They got 305 for A. They got 36 for angle B. And I don't know if they found C. Let's see, C. Did they find C? I don't think so. Now, here's where they can add a little bit of, a little bit of stuff to it, and you have to think a little bit. Two stations are on an east-west line. Now, you have to read these paragraphs. East-west line forms a 90-degree angle. I'm sorry. 180 degrees. All right, so 110 miles apart. A forest fire is located on a barren of north 42 east. Well, north 42 east means that it's in the first quadrant, this quadrant right here. Okay, that's northeast, 42 degrees. Comes off of north. I have to explain that because some people don't understand that. All bearings come off of north or south. Okay? Bearing of north 42 degrees from the western station at A. 42 right here. So that means that this is 48 because it makes a 90-degree angle. North and east make a 90-degree angle. All right? And 15 degrees at station B. So that means this is 105 because it's more than 90 degrees. How far is the fire? How far is the fire from the western station? They want B. All right, draw it up. And what they're getting you to do, this is basically a free body diagram, except it don't have forces on it. It has lengths and angles. And when you put a force on it, then you're talking about a free body diagram. So we got 3 points. And we've got 48 degrees. This is angle A, equal to 48 degrees. And we've got angle B, which is equal to 105 degrees. And of course, angle C, which is 27 degrees. We've already done that for you. And all they just want one side. They want B. So when you're doing this problem, and you know you only got to find one answer, you go right to that answer. So that'd be B over sine of B equals, and they've got a side that they've given you. I didn't write it down. And that's this side right here is 110. Now you have to tell yourself at this point, you have to say, okay, what am I given? I'm given C. That's C. So I've got to use C and the sine of C. Cross multiply. B is equal to 110 times the sine of 105 divided by the sine of 27. Somebody would give me a whole number, please, for that one. Y'all awake or y'all doing it or what?
Yes, sir. It should be 235 miles.
235. So B is equal to 235. Now that's how you do it and not have to do the whole thing. They just give you one thing. Say
it's
again?
234. It's
234.
Sorry about that.
All right. Okay. Here they just ask for one thing and you do it. So that's 3. How many test questions is that? 3? That's about 3 test questions I've done. And let's see what they got. $234. It's a miracle. Okay, for blah, 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 blah. Supplementary. Okay, they're talking about possible cases here. there's some cases to where you can't have an answer. Sine of B has to be greater than 1. Sine of B has to be equal to 1. Sine of B has to be between 0 and 1. And sine of B sub 2 has to be between 0 and 1. There are some things, but I'm not going to try to trick you. So, okay, it says right here, solve the triangle ABC if B is equal to 55.4 or 5540, little b is 8.94, and A is equal to 25.1. Well, okay, here it is. You're going to go through and you're going to do it, and you're going to get sine is equal to 2.31 meters. Sine of A cannot be greater than 1. The triangle does not exist. So you got to be careful. Now, I'm personally not going to ask you one of these on the test, but you have to be weary that sometimes if you get something crazy and you don't get the sine of A cannot be greater than 1 or something like that, you know it's not a triangle, just go with it and say it can't be a triangle. But I'm not gonna ask you these on the test. See, that's why. There's 8.94 right there, and if you have a length of 8.94, it's never going to reach this because the angle is too big. It's never going to reach that. So there are some instances to where, and plus, if you was to draw this, you would see that there's no way that 55 degrees would give you a touching vector between 55 degrees and that line right there. So just sometimes there can be no such triangle. Here you have ABC is 55. Let me see if there's, yeah. This one can be actually two different triangles. Okay, again, I'm not going to give you these on a test, but you need to be wary of them. Okay, because you could actually have two triangles with a distance of 22.8. Okay, you could have one way out here, or you could have one here, because the arc swings. And this is how we used to find pins out in the field. You got a distance here, and you got a distance like this right there. All right. If you take this line right here, we'll call it angles line C, and you was to take that angle and you was to swing it. Like swing it right there. Then angle C would also be a distance right here also. And that's what they're showing you. That with any triangle, you could have two possible triangles if you swing one side with the arc, because that's the way an arc works, a line. You swing it, it'll go down here, and it'll come up, and it'll hit it again. So you have two possible solutions. This one and this one, which is right here. And they're just telling you this because they want you to be wary of it. I'm not going to give you one like that on the test, but you need to be sure that you understand that you can have an impossible angle and you can have an ambiguous, which means that it could be one of the, swing that over here, it hit right about there. That's the same example. Okay. This is just a rundown. And if you want to write that down, that's fine. If sine of b is greater than 1, then no triangle satisfies the given function or condition. If sine of b is equal to 1, then one triangle satisfies the given conditions, and b is equal to 90. If sine of b is between 0 and 1, then one or two triangles satisfy the conditions.
Gmail.
Here's another example. Solve the triangle ABC given A is equal to 43 degrees. So we can just draw this one. We know what 43 degrees looks like. I mean, we'll just draw an angle right here, and we'll call it 43.5 degrees. Okay, we know that A, okay, since we're given A, we know that this A over here, that's A, little a, y'all draw this while I'm drawing it, is equal to 10.7. And we got C. C is usually right here. And C is equal to 7.2. So here's what I've got. That's what I've got right there. Now, of course, we can go ahead and find angle C. And let's just see what we got here. So 10.7 over the sine of 43.5 is equal to 7.2 over the sine of C. So cross multiply, and we're going to get 10.7 times the sine of C is equal to 7.2 times the sine of 43.5. And I'm going to divide by 10.7, divide by 10.7. Now I've got the sine of C is equal to some number. So let's go ahead and figure out that number. Clear. 7.2.
27.6.
27.6. Now that's the sine of C. That's not C, that's the sine of C. So if we want to find C, then we got to do the inverse sine of 27.6. So somebody do the inverse sine of 27.6 for me.
Oh wait, I think I gave you the wrong info. I think the final answer was 27.6, but the above should be like 0.4631.
Okay. All right, do that for me. What's this point what?
0.4631.
Okay, now take the inverse of 0.4631, and that comes out to be what?
Then it comes out to be 27.6.
27.6 degrees. And that would be C, 27.6. And now if you wanted to fill the rest of it out, you can add 27.6 plus 43.5 and subtract from 180. And what does that give you? Just give me a
108.9.
And of course, you can find B by doing the law of sines and cosine. I'm not going to worry about that. And they got 27.6. And the other one, we're not going to use the other one because that'd be more than 180. And that's the law of sines and cosines. So what I want everybody to do tonight is I want everybody to jump on the homework and try to do a few. I don't want you to do them all. I just want you to do a few. Okay, let's look at the law of cosines right quick. And the reason I'm showing you both, some of you know the material a little bit more than some of you that don't. If some of you want to move on, that's great. Some of you want to take your time, that's great. We've got Thursday and Tuesday to do everything, but I want to keep Tuesday open for vectors. Okay, so let me get out of this. Let me go to 11.2. Again, we're just plugging and chugging. I'm not going to go through the derivation. There's is your law of cosines. Now you need to know what you're looking for. And if you label your triangle, you'll know what you're looking for. Because you'll know what's plugging, what you have and what you need. So with that being said, I'm going to look at the first problem. And there it is. So let's draw it. We've got triangle looking like that. We got angle A is 52 degrees. B, we don't know. C, we don't know. But we've got side B as 5. And little c as 11. Now, what I'm going to pull up is my law of sines and cosines. I'm going to look at these right here. And I've got A, I've got big A, I've got little c, and little b. Looks like to me we're going to use the first one. Because we've got the cosine of angle A. We've got angle A, B, and C. So I'm going to use A squared is equal to B squared plus C squared minus 2BC cosine of A. At this point, I want you to go ahead and plug that in. Parentheses squared plus parentheses squared minus 2 times parentheses cosine of parentheses. Well, B is 5. C is 11. And A is 52. See there? You plugged up all the holes. You just got to find which one of your holes, which one of your equations match the holes in your problem. A squared is equal to 25 plus 121 minus 2 times 5 is 10. It's 110 cosine 52. Well, all these are numbers. So all you got to do now is find the cosine of 52 and multiply it by 110. So take your handy dandy calculator and do 110 times the cosine of 52. And I better put, well, maybe it'll enter 67.72. Check me. A squared is equal to 25 plus 121 minus 67.72. So 25 plus 121 minus 67.72. That gives me 78. A squared is equal to 78.28. And I'm going to raise that to the 0.5 power. 8.85, whatever. 8.85 units. Or in this case, since the whole numbers are 11 and 5, we could round that up to 9 and say that little a is equal to 9 units. Now that I've got the sides, I can do law of what? I can do law of sines. So let's say I want to find, let's say that we don't know what, let's say this is C and this is B. Take your pick. You want to find angle B or angle C? Somebody pick one.
Let's go with B.
B is in Bravo. So sine, I'm sorry, 9 over sine of 52 equals B over sine of B. So 5 times sine of 52 over 5, or sorry, 9. And that's equal to the sine of B. Of course, you need to take the inverse sine. So sine inverse of 5 sine of 52 over 9. And what does it come out to be?
I got 25.9.
25.96. We're going to raise it since the angle is in whole numbers. We're going to raise that to 26. So go back to our picture. B is equal to 26 degrees. So that's 78. So C is 102. Somebody check me.
Yeah, that sounds about right.
And that's all there is to it with law of sines, law of cosines. So let's see what they got. $8.8. We got, I went up to 9. That's it. They just wanted that. But you see, after you do that, you can use your law of sines to find the other stuff. All right. So we will continue with law of cosines when we get back Thursday. What y'all need to do for homework is you need to work on 11.1, and you can start on 11.2. And if you don't feel comfortable doing it, then stop on after 11.1. Send questions, and I will take the roll here in just a second, and we will see y'all after Thursday. I'll see you.